Today I'm going to present my presentation, which is on reporting and documenting a specific small building in New Zealand construction industry, presented by Mohammed Shafil Sayyad, that's my name. So basically, why is small building design important? So the first point is it's affordable. They are very cheap compared to large buildings. And the second one is rising land price. Design. In New Zealand, there's a lot of rising land price at the moment, so it's better if you design a small building, and it uses fewer materials and energy compared to larger buildings. For small building, they use fewer materials, labors, and AC, heaters, and energy. And the last one is minimize waste and construction time. Large buildings takes a lot of time to construct, whereas the small buildings takes very less time to construct. And the second one is functionality, sustainability, user needs, how it impacts the design processes. So firstly, the functionality, it ensures the building works well for its intended use. For example, like designing a library, you have to make it in a quiet study area where noise cancellation is taken care of. Noise taken from outside doesn't come in, and the noise from the inside doesn't go out. And the second one is sustainability. It involves using eco-friendly materials and energy-saving designs, like installing solar panel designs on a home. Installing solar panels on a home, it doesn't affect our environment, and it's a good thing from sustainability. And the third one is user needs. The design must be comfortable and accessible, like including ramps in a building for those people who have wheelchair users. And material, how it impacts. Choosing strong and durable material affects the building safety and longevity, like using steel for a bridge. The fifth one is time. It's about balancing how quickly the building is completed with maintaining quality, such as finishing a hospital before an important deadline. So if you finish the construction before a time, then there will not be dispute resolutions. And the last one is cost implications. The design must stay within the budget while meeting all needs, like building a small office with affordable materials. So you can see some pictures here of materials: bricks, cement, concrete, sand, and plastic, wood, tiles. So the design criteria in assessing design loads. So design criteria simply means the loads and material properties. And the material properties, you have to assess the strength, ductility, and durability of the materials. Example, how strong concrete are from timber and how strong the steel are from concrete. Using the code compliance, adherence to relevant building codes and standards. So you have to keep in mind of the code and conducts. So load types, there are two types of loads: dead load and live load. Dead load simply means permanent loads, and live loads are temporary loads. So dead load is the weight of the structure itself and any permanent structure, and live loads are moving structures like furniture, people. And the last one is serviceability. The building should stay comfortable and functional due to no excessive bending or vibrations. Safety factors in assessing design loads. So there are some safety factors, and some of the safety factors include the code compliance, where we should follow local standards, code compliance, and the ductility and flexibility. Design structures to flex and absorb energy without failing. So foundation safety. The next one is foundation safety, where you should use safety factors for soil strength and behavior. If the soil is soft, then you should have a large foundation, good foundation for it. And load safety factors increase expected loads. Example, multiply by 1.5. And if a building is made for a school, then there should be 90 students. So we should multiply by 5 because it might have some gatherings. So we have to be prepared for it. And the next topic is exploring factors influencing design criteria selection. So when selecting design, you have to keep in mind of the location and environment. So the first one is climate. The climate of the temperature. The temperature should be good. And what about the rainfall and the wind conditions? And the next one is seismic activity. Some of the time earthquake risk and soil conditions are a major use, so we should keep in mind when selecting a location. So building use and function. So the purpose of a residential, commercial or industrial needs. If a residential home is needed, so what is the purpose, what is the space needed, and if an industrial needs, industrial building is made, what's the purpose and what's the intended use, so the regulatory requirements, the building codes, local standards and regulations should be followed, and all the permit and approvals should be compliant with legal and safety. Just because if you don't want any fines in future, so you should have all these permits and approvals. So the next one is analyzing key structural elements in foundations and substructural requirements. Number one is key structural elements. Beams. As you all know, beams transfer load from floors to the columns, and it must be strong enough to support expected loads without excessive deflection. And the next one is columns. Function of it is support vertical loads from beams and transfer them to the foundation. The design should be designed to handle compressive loads and maintain stability. Walls function is to provide lateral support and enclosed spaces. And the types of bearing load bearing walls, it supports structural loads versus the non-load bearing walls, it supports the partition only. And we have slabs here, which provide horizontal surfaces for floors and ceilings. And the design must be to support light loads and dirt loads while minimizing deflection. And some of the foundation requirements. So the footings, the function is to distribute loads from the building to the soil. Footings. And the types of footings are shallow footings, example spread footing, strip footings, and the deep footings are piles and caissons. And the design is load bearing capacity. It must be designed to handle loads from the structure and transfer them to safety to the soil. And soil testing, you should have conduct soil tests to determine the type of strength and soil for proper footing design. And the settlement, we should consider ensure the foundation minimizes differential settlement and avoids structural damage. Number 3 is substructural requirement, and the first one is basement. The function is to provide additional space below ground level. The design, it must be designed to waterproof and designed to handle soil and pressure groundwater. We have retaining walls in sea walls, and it supports spoil and prevent erosion. And the design, it should be strong and enough to resist lateral earth pressure and prevent movement. We should have proper drainage to manage water around the foundation to prevent damage. And it should include proper drainage systems like French drains and some pumps to keep the foundation dry. And the last one here is ventilation. The function of a ventilation is to ensure proper airflow under the building to prevent moisture buildup. And the design is incorporate vents and air gaps are needed. In conclusion, effective building design in New Zealand requires careful attention to structural elements, foundation and substructures. Key components like beams, columns and slabs must be robust to handle loads, while foundations need to suit soil conditions and manage settlement. Proper design of substructures ensures stability and drainage, and following local codes and addressing seismic risks are essential for creating safe, durable and functional buildings. So you can see the conclusion, and at the last I want to thank you all for listening, and here's my references for my presentation. And do you guys have any questions?
Yeah.
Thank you.
Yeah.
I have question. What is the benefits of a small building compared to the large building?
Nice question.
So some are benefits of small buildings. So small buildings are more cost effective compared to large buildings, as they use less labor and less materials are being used. And the second one is speed of construction. For small building, the speed of construction is very fast, quick, and for the large buildings, the construction speed is very low.
I have a question.
Yeah.
Why foundation is very much important in small buildings in New Zealand?
So In New Zealand, they want to ensure that the building stays for long and the building is durable, as the soil conditions, some of the places the soil condition is very low, and so we need to have good foundations. For this good soil, we have shallow foundations, and for the hard soil, we have to have a shallow foundation, and the bad soil we have to have a deep foundations.
So we have to make foundation according to the place, or we can just make it whenever and however we want to make foundation.
No, we should have. It comes under the building codes, so we should make a good foundation.
Like, do we have to see the climate and weather before
Yes, yes.
foundation?
Yes, if it's bad place where earthquakes usually comes, so we need to have a good foundation for it, like a deep foundation.
Yeah. Thank you so much. Good job.
Thank you for listening.
Thank you
Why
so much.
small building is